All right, so this video is on your 6.3 notes, Intro to Matrices and Basic Operations. So here on the right is an example of the matrix that comes in a bracket. The matrix it's called a rectangular array of numbers. It can have different dimensions, just like you would, measure your room or a box. It could be 3 by 2, 2 by 4, 4 by 5, depending on how many rows and how many columns do we have. Now, dimensions are calculated by rows and columns. So rows are going to be right here. Oopsie. Hold on. All right, rows are going to be across. So right here, and then columns are going to be on the top, which is right here, okay? So this matrix has 2 rows times 3 columns. Okay, so again, rows, it's just like in the movies, you would come across, and then columns is going to up and down. Okay, now elements represents the individual number of matrices. So what do I mean by that? I'm going to talk about it in just a second, but the elements would be, let's just say a number 11. It's in my second row and the third column. Okay, so second row and the third column would be number 11, but we're going to talk about it in just a second. I do want to mention, so today you're going to use, after today you're going to learn how to use matrices to represent data and perform simple operations. I do want to, few students have asked throughout the class, what is it that, why are we learning matrices? Okay. So I just want to, mention a few examples of, why do we learn to do matrices? So you can encrypt words. A very common use for metrics in daily life is using encryption. So we use it to scramble data for security purposes of different codes, code and decode. Games, especially in 3D, the applications are in matrices as well. Economic and business. What else? We have dance. You can choreography a dance using matrices. Animations, it can help make animation precise and accurate. Construction, another common application for matrices in real life is construction. Have you seen buildings that are straight, but sometimes architects try to change other structures of the building? This can be done with matrices as well. And then physics, we apply matrices are applied in the study of quantum mechanics, electrical circuits, and optics as well. It helps the calculation. So, very important, often used in life. So I just wanted to mention that because I had some questions about that. Okay. All right. So I have right here, I have also reposted that matrix. Okay. Now, the first question asks, what are the dimensions? So we already said that the dimensions are 2 rows by 3 columns. Okay, so 2 rows by 3 columns. The rows will always come first. Now, identifying the element. We said that the element will be a specific number, right, that we are trying to locate. So if I'm looking at identifying the element 2A22, that means first number 2 represents a row, second number represents a column. So that means I am looking at the number at row 2, second column. So number 5. Okay, that's the number I'm looking for. Second row, second column. A13. Again, 1 represents a row and 3 represents a column. So I'm looking into a first row and a third column. So it will be number 15 is the number I'm looking for. So again, first number represents a row, second number represents a column. Okay. Now, we're going to learn how to add and subtract matrices today. Just so you know that to be able to add or subtract matrices, they must have the same dimensions. They must have the same shape, okay? Add and subtract the corresponding entry. So that means that when I am adding and subtracting, each number has to correlate with the other number, okay? So whatever the place number is, so they got to be in the same shape, okay? If they're not, you cannot add them. All right, so looking at matrix A, it is 3 it is 3 by 2. Okay, so you got 1, 2, 3 rows by 2 columns. Okay, and then B is also 3 by 2. Okay, so we are good to go. We can add both of these matrices together because they have the same shape. So I'm going to write them out for you. Okay, so you get 2, 9, -6, -5, 3, and 1. And what we're adding is 1, -4, 2, 1, 5, and -9. Now, we're simply adding the corresponding numbers. A number with in the first place with a number with the first place. Okay, so 2 plus 1, 9, plus -4, -6, plus 2. We got -5 in this line, in this position, plus 1. We have 3 plus 5, and 1 plus -9. Okay? Now, of course, you're going to add them together. So you are going to get a 3, a 5, -6 plus 2, it's -4. -5 plus 1, it's -4. Then an 8, and then 1 plus -9, it's -8. Okay? And that's your answer. That's your new matrix. Okay? All right. If you need to write that down, pause the video. All right. Now for number 4, we have a matrix B and a matrix C. So we are not able to subtract them from each other because they are different shape. This is 3 times 2 matrix dimensions. This is 2 times 3, okay? So they are different shapes, so we are not going to be able to perform that one. All right, so we're going to move on to number 5. So we got a matrix B and matrix A. They are the same, so we're going to subtract them. So this is 1, -4, 2, 1, 5, -9. And we're subtracting A, which is 2, 9, -6, -5, 3, and 1. Now, in Desmos, in Delta Math distributes the negative first to each number inside the matrix, okay? So, I want you to be aware of that because some students had some questions. So, the way Delta Math does it is it repeats the first matrix, okay? Distribute the negative first to the second one, then this middle sign changes to addition now. Now, the 2 becomes negative, the 9 becomes negative, the 6 becomes positive, so you're basically changing the numbers. Now, of course, you're distributing the negative to -5, so it becomes positive, this 3 becomes negative, and -1, 1 becomes -1, and now they're adding it, okay? I don't do it that way, but if you're comfortable with that method, that's fine. So I'm going to erase that very quick. The way I do it is I just simply add and subtract what's given, okay? So let me erase that very quick. All right. Okay. So for me, I'm just going to do first number minus the first number in the first column in a row, -4 minus 9, 2 minus -6. Gotta remember you're subtracting the negative, okay? 1 minus -5, 5 minus 3, and -9 minus 1. And I'm just simply gonna combine them and do the operation. So 1 minus -2, it's going to give you -1. All right, -4 minus 9 is -13. 2 minus -6, this is going to become a positive. So it's going to be 8 because negative and negative makes it a positive. Here you're going to get a positive again, so you're going to get a 6. 5 minus 3, it's 2. And -9 minus 1, it's -10. And that's your answer. So whichever method you choose, it's fine. All right, next question. So here we are going to multiply a constant times a matrix, okay? So we got a 3 in the front of the A, all right? So all we're doing is distributing to every single item inside that matrix, okay? All right, so again, I am distributing the 3 and multiplying every one of them, okay? So, 3 times 2 is 6, 27, 3 times negative 6 is negative 18, 3 times negative 5, it's negative 15, 3 times 3 is 9, 3 times 1 is 3. That's your answer. Now, if you need to pause that to write it down, please do so. Now here you have a fraction for number 7. It is negative 1/2. And again, you are multiplying it by a matrix C. So you got 3, negative 6, 3, 8, 2, negative 1. Okay? So again, you're distributing it to every single one of them. So you are multiplying negative 1/2 times 3. Okay? Negative 1/2 times negative 6. And negative 1/2 times 3 again. Okay? On the bottom, we have negative 1/2 times 8. We have negative 1/2 times 2. And negative 1/2 times 1. Okay? Scrolling down a little bit, we're just going to multiply these out. So remember, this is a fraction. Okay, so the first, it's going to be negative 1/2 times 3. It's negative 3 over 2. All right, negative 1/2 times negative 6. That's going to be positive, because negative and negative makes it a positive. 6 over 2, which is 3. Okay? Just want to make sure everybody understands what happened here. We just simplified it. All right. Negative 1/2 times 3, it's again negative 3 over 2. On the bottom, we have negative 1/2 times 8, which is negative 8 over 2, which is negative 4. Next one is going to be negative 1/2 times 2. So again, negative 1/2 times 2, it's negative 2 over 2, which is negative 1. All right, because again, 2 goes on the top. So you're going to get negative 1 here. And then lastly, negative 1/2 times 1 is simply negative 1/2. And that is your answer. So again, if you need to pause that to write it down, please do so. All right, number 8 is 2 times b minus a. So of course, first we are going to do multiplication. So we're going to take a 2. We're going to multiply it by b. Okay. So b was 1, negative 4, 2, 1, 5, negative 9. And then we're going to subtract a from it. So it's going to be 2, 9, negative 6, negative 5, 3, 1. So first, of course, we are distributing, okay, 2 into everything. So we're going to get 2 times 1 is 2. 2 times negative 4 is negative 8. 2 times 2 is 4. Now we're doing the same thing here. Okay. So 2 times 1 is 2. I had it correctly? Yeah. 2 times 5 is 10. And 2 times negative 9 is negative 18. Okay. And now we're subtracting. So again, you can distribute the negative and change it, their signs, and then add the terms if it makes it easier. I'm simply just going to go with subtraction. So 2 minus 2, okay, is 0. Okay. Now, next one, you're going to have negative 8, all right, minus 9. Okay. It's going to be more negative, which is negative 17. Okay. 4 minus negative 6, it's going to change to a positive. Negative and negative would change to a positive right here. So that's going to be adding to a 10. 2 minus negative 5 right here. Again, negative and negative change to positive, so that's going to be 7. 2 minus 3, it's 7. And negative 18, 18 minus 1, it's again negative 7. Negative 19. Okay, so negative 18 minus 1 is going to be more negative, which is negative 19. Okay, and that's your final answer. So again, distribute first and then subtract. All right, so here's just saying for you try. So if you need to pause it and try it first and then watch me do it, go ahead and do it now. All right, dimension of f. F is 1, 2, 3 rows times 1 column. Okay, so it's going to be 3 times 1, 3 by 1. Okay, 3 by 1. All right. Element. Element D31. So again, 3 represents a row, 1 represents a column. Okay, so 3 represents a row, 1 represents the column. So we're going to look at D. So we have a third row, 1, 2, 3, first column. So number 9 is the element we're looking for. Okay, all right. Now we're going to add E plus F. So we're going to add these two, but we cannot, they are different shapes, so that's not possible. Okay, not possible, because again, E is 1 row by 3 columns, and F is 3 rows by 1 column. So we cannot add them or subtract them together. All right. And C, which is going to subtract number 4, it's C minus A. Okay, so my C is 2, 9, negative 7, and 3. And A is minus 3, negative 1, 4, and 0. Okay, so again, for my new matrix, 2 minus 3, it's negative 1. Negative 7 minus 4, it's more negative, so that's negative 11. 9 minus negative 1, so that's a positive switch, so that's going to be a 10. And 3 minus 0 is just 3. So for this one, you should got negative 1, negative 11, 10, and 3. Okay? And then the last two, I repeated the same matrices, so it's easier for us to see. And next one, we are multiplying the 2 first to a C. And then we're adding an A. So that's negative 7, 9, and 3. And then we're going to add 3, 4, negative 1, and 0. So first, we're distributing. Okay. So my new matrix for C is going to be 4. 2 times 2 is 4. 2 times negative 7, negative 14. 2 times 9 is 18. 2 times 3 is 6. And then we're going to add matrix A. 3, negative 1, 4, and 0. All right, and then combine them. 4 plus 3 is going to be 7. 18 plus negative 1, it's going to be 17. Negative 14 plus 4, it's going to be negative 10. And 6 plus 0, it's 6. So your final answer should have 7, 17, negative 10, and 6. Okay? If you need to pause that to write that down, please pause it now. All right, and the last one for you, number 6. You're distributing a fraction of 1/4 to a matrix A. Let's see what matrix A is. 3, negative 1, 4, and 0 again. Okay. So again, all we're doing is distributing. So 1/4 times 3 is going to be 3 over 4. 1/4 times negative 1 is going to be negative 1/4. 1/4 times 4 is going to be a 1, because 1/4 times 4 is 4 over 4, which is a 1. And 1/4 times 0 is simply a 0. Okay? Now, I do want to show you guys that you can do all that. I know that this was a lot of work. And you guys are required to learn how to do it by hand. But you can do all this by using a matrix calculator. All you have to do is Google. It's not the same as scientific calculator. You got to Google matrix calculator, and you're going to go to in Desmos. You have a new matrix right here that it tells you rows, and you can change them and add them and play around with it if you want. Let's just do example 5. That was 2C. This example, we're going to do this example 2C plus A. So you're going to go to Desmos. Oopsie. Where is it? You're going to go to Desmos right here. I am going to put A matrix right here first. So that's 3, negative 1, 4, and 0. Okay. So that's for A. Oops. It was, I'm sorry. Negative 1 was here. 4 and 0. All right. Now I'm going to do a new matrix. Okay. We'll make it this one. I'm going to clear this one. I'm going to make a matrix C. Okay. And I'm going to put in my C, which was 2, 9, 3, and -7. Okay. Now, you're going to go to this enter blue button right here on the right corner. And now in this next line, you're going to put 2 and whatever the equation is, C plus A. Okay? And boom, it gave you the same answer as we had. 7, -10, 17, and 6. Okay? We had the same answer right here for this question. So again, you can use matrix for anything. If you want to do question 6, which is just 1/4 A, again, you can clear this one and we can clear C. Okay? And then again, we can put in this line 1 divided by 4 times A. And again, it's giving you the same dimensions, just in decimal, of our matrix right here. So 3/4, -1/4, 1, and 0. Okay? All right.